Hey everyone, my name is Joe Dorr from Brighton Science. You're joining us today in our lab with my colleague Charlie Becher. We're here to just demonstrate a little bit of the functionality of what our device is able to offer in regard to validating surface prep in the aerospace industry. So Charlie, when we have conversations with folks in the industry, what are some common ways that they say they validate their surface prep?
Yeah, so in traditional manufacturing, we're seeing things like dyne pens and water break testing being used to qualify surface cleanliness. A couple things, dyne inks are very subjective and potentially hazardous. They can be destructive on parts and potentially hazardous to your employees. When we look at water break testing, you're really getting a binary analysis of that surface. So it's really only giving you a go, no go. And what we do is quantify that water break testing in the form of water contact angle to actually assign a value to that measurement for increased process control. So we've got our handheld device over here that Joe can take a couple measurements and show you how quickly we're actually able to generate data.
Sample 1 here, we have an aluminum coupon. Sample 2, a composite coupon. So you see there in a few seconds, we were able to obtain measurements on 2 different material types. Charlie, how long would it take to do a water break test on both these samples in a traditional sense, like water break?
Sure. Yeah, water break testing could take anywhere from 5 to 15 minutes per part. And once again, you're only getting that binary answer. With contact angle, what we're able to do is assign a number to that actual contact angle value and inform process improvement by actually generating data at different critical process control points in a way that water break cannot currently do.